And we are going to say, I can determine the volume of cones. Find the volume of this cone. Well, first of all, let's talk about the signal words. Surface area, it's the same as with any other shape or any other figure. Surface area, signal words are cover, outside, wrap, or build, and square units, of course. Volume signal words are inside, capacity, fill, space, hold, or cubic units. Okay, so let's look at this figure. The one that comes straight down and forms that right angle, that's your height. So we typed it in Desmos, height is 12. This over here is your slant height because it goes down the side. Fortunately, we don't need that for our volume formula of a cone. And our radius. This 10 goes from one side of the circle all the way to the other. So to make it a radius, we need to take that 10 and divide it by 2, which gives us a volume of 314 cubic inches, or inches raised to the third power. Now a cone and a cylinder with the same size, base, and height have the following relationships. A cone has 1/3 the volume of a cylinder, which means it's smaller. And a cylinder has 3 times the volume of the cone. If you had a cone and you filled it up with sand and they had the same base and height, it would take 3 of those cones filled to fill the cylinder. Okay? And you can tell that because 1/3 means smaller, and that is in the formula for the volume of a cone. Filling a cone-shaped party hat with candy. The hats have a height of 8 inches, so let's go ahead and put that in. Height equals 8. And a diameter of 6. Now remember, we'll need radius. So if we have diameter of 6, we have to divide it by 2 to make it a radius. Which is the closest to the amount of candy Jason can fit in each of those hats? So I have written the formula for the volume of a cone, 1/3 pi r squared h. And we have our height and we have our radius. So that gives us 75.4, or 75 square inches worth of candy. All right, so let's go to the next one. It says the cylinder and the cone shown below have the same size base and height. All right, so let's just look at them first. This cylinder is definitely going to have more space in it than this cone. It says, create a statement that accurately describes the relationship between the volumes of the two figures. So let's see. The volume of the cylinder is 3 times the volume of the cone. I guess we also could have said the cone, the volume of the cone is 1/3 the volume of the cylinder. So you could have done it either way. So let's just try it. The cylinder is 3 times the volume of the cone. And then let's go ahead and do it the other way just so you can see it. The volume of the cone is 1/3 the volume of the cylinder. All right, let's go to the next one. Miss Benson wants me to stop.